Okay, so in the next solution we have is, after early stopping, is to increase depth. Okay, and this is where we know 那个什么 deep neural networks. Okay, so for example, 如果说我本来是用 AI， 然后 W， 然后 AH， 然后 W， 然后AJ. Alright, then to solve it, I could do this. For example, if I have this case here, okay, and I have to map this input to this output, all right, and I find that I may end up doing something like, in order to make 可能就是一开始我没有办法 solve 这个 or something about the input and the output 就没有办法找到一个solution of 这些 weights that will reduce 我的那个 delta 到零够的那个 threshold, right? If you recall, in backprop, one of the criteria we have was that if the delta is less than some fixed threshold 我们才停嘛 right? Let's say 我们有一个 problem set 刚好在这个 architecture 我们没有办法把那个 delta 降到那么低 so what we might end up doing is to do something like this. We might decide that, perhaps it's because 我的 hidden layer 不足够的 nodes, so I increase the number of nodes, okay, to solve 那个 problem, and you will solve it, right? It's some level, because 你 increase 的这么多，你本来就可能有3个 unit 或4个 unit， but 现在你有100个 unit, so 当然这样子给你很多 resolution 来去矫正这些号码 right? Okay, so but this is not deep, this is flat, this is making it fatter. Okay, now what we mean by deep, and it will solve it but it will overfit. Okay, 这样子做法会 solve it will overfit, but if we go deep then it's actually more efficient and actually more generalizable. So when we go deep, for example, we might do something like that. Okay, so AI, so we'll add more layers. Okay, all right, and why does this work better? Okay, for 2 reasons. One is you realize that because this is not deep, okay, 它就会 overfit because 它就只矫正这个 parameter 或这个 parameter, okay, and it will fit this data to this data, or this one will only care about this data. Okay, it doesn't really care about anything beyond just 这边跟这边直接的关系，就 numbers 而已。Okay, but if we go deep, 你可以看的就是说这个 care about 这个 but in caring about this one, it's also caring about something else beyond just input. 好像有多一个东西，除了只是 input, 它还是要 account for input 里面还有多一层这样子。Whereas 这边就是只是管基本上这样子或这样管 input, then that seems about it. There's only one layer of abstraction. Whereas if I go deep, I have opportunity for deeper, more layers of abstraction. And the more abstract I can get, the more generalized I can be. Okay, if 就是说 instead of saying, e.g. 如果我要说 if I do a simple number, 10 equals to 10 times 1, 这样子，这 doesn't tell me much except that it's a tautology, right? 10就是10这样子 ，okay, 没有什么 information. But I can imagine if I do this, it's more like 5 plus 5这样子 in the sense that this does not tell me, this just repeats the answer. This tells me that the answer is made up of 2 components, each of which take up half or something like that. Okay, I can go more complex solution, for example, you know, or 2.5 times 2,就是 you can imagine I can generate an infinite number of more complex solution, but and each of these more complex solution will give me a deeper understanding of the quantity of 10. That 10 can be made up of what does 10 mean, right? This is 这样子就好像 10 is 10, 没什么资讯, right? This is trying to say maybe 10 can be made up of some 5 plus 5 or some 2 plus 3 plus 5 or some other more complex, deeper thing than just the immediate relationship of 10 to 10. Okay, this gives me more space to have a richer set of functions that equivalently match 10 to 10. That's what the deep means. That's what the deeper is doing. Does that make sense? Right, in the sense that I now have a more abstract, 更深的、更基础的 understanding. 我的 network 可以知道 the meaning of 10.
所以有点像它的 capacity 有更多的分了几倍，然后这几倍再区分几倍。
没错，没错。Hierarchical.
那这两个 training error 可以降到样低，就是说
It is possible that 对 so 就在 training error in the sense that let's say we fix it so that 其实我的要求也是一样，跟这个一样，跟这个一样，跟这个一样 ，right? So that they both perform in terms of training error 的话 they both perform the same, let's say. But the difference would be if I give this one more data, new data, 它就会犯错误。But if I give this one new data, 它可以用这些其他的 solution 来去解答 ，and 可能它比较不会犯错误。Right? Within the training error, 它就一样的解答，两个都一样 ，but for that given data set. But then the trick would be if I give you new data set, right? Will you still be able to solve it correctly? Okay? So this is one benefit, is when you go deep, what it means is you are giving it more alternative operations to apply to solve the problem sets. So with more possible operation in your tool belt, then you can be more generalizable. Yeah. Whereas here it's only one fixed operation, right? You only have you may have a lot of hidden units, yes, but they are still all just doing 这个乘这个加这个乘这个加。Whereas here 你可以说这个乘这个加这个乘这个加这个乘这个 you know? That's why I use this example like that. Okay, mathematically 是这个意思啦。Okay, so this is one benefit of deep neural network and how it by increasing the depth we address the overfitting problem, and that's one way of why increasing depth works to solve this problem. Another added benefit is 你发觉到就是说 if I can, in order for me to solve 这个 AIAJ, 如果这个没有办法 solve, for me to increase 这个我就要 estimate 这么多 weights. Okay, so the number of parameter I have to estimate is a lot. Okay, it turned out that actually even though I increase these nodes here, the number of weights I have to estimate is there's a balance point where this number of parameter will be outwin this number of parameter. Okay, to solve a problem of some level of complexity, 可能这个我就要很多才可以 achieve 你说的那个 error rate. 如果要降到什么程度的话 right? I probably need so many weights. But here, all I do is add 2 layer. 可能这么会比较多 weights, but still less than this one. Okay. So in other words, it's not only able to resolve 那个overfitting 的问题，it can also be in some ways, in some cases more efficient even. In fact, 你可以这样子做。You can show that for certain types of problem, actually you don't even need to have equivalent size of the hidden layers. 你可以说我的 AI 是这样子 ，but 我也可以 shrink 我的 AH 这样子 ，alright? I can even do something like that, right? And definitely I will reduce the number of weights. Okay, so deep neural networks 真的是很厉害 because it has these very two fundamental powerful things in the way it works. First, it gives the network a bigger range of operations to tuned operations to use. Second, because of it being deeper, it can afford to discard redundant parameter that actually you don't need to solve the problem. And in doing these two together, it solves the overfitting problem very powerfully. Okay. And so for that reason, it is likely actually that our brains are more like this, right? And clearly it is. Clearly 我们的 brains 大概是这样子。Okay.
第二点
啊？
怎么样？什么证据说一定
That our brains are like that our brains are deep rather than wide. It's true 嘛？因为我们的 brain 不可能代表 the whole infinite world with a whole infinite cell action with the same whole infinite in between 嘛？我们的 brain 一定是比较 narrow than it is wide at the end, at the extreme. And it is narrow in the sense that 它不是 narrow then 就是只是一层啦，它是 deep and narrow. 它 you know 它就往内钻，它不是往大长，它是往内钻这样子。Okay, so as a principle of growth and structure, it is likely that our brain, a deep neural network is a good simulation of our brain in that sense, in a general sense.
不然的话 AJ 是不是应该要小之类的？
小吗？
因为我们能够 output 的就那些。
Good question. I don't know, but you have to think 我们的 output 是 muscles. Yeah, it is true. If you want to be very very accurate, it's possible that it may look something more like this. 就是说我们的 number of at least in humans, I don't know other animals, right? But in humans, you have your eyes, you have your nose, skin, ears. What else? Tongue, tongue sensors, 大概吧，And you can imagine eyes alone 就是 billions or millions of receptor 了这些都有啦Whereas your muscles, 你的身体大概只有 in the order of hundreds of muscles. Okay, maybe each muscle fiber 可能有几千个 subneuron, but still nowhere near millions. 可能啦，可能是这样子。But still, it's to reduce the problem, right? Yeah. Okay, so this is a deep neural network, and 刚刚讲的那个regularization, early stopping as the most common way that you might see to resolve 那个overfitting problem. Okay. 好 So then next problem. Let me stop this.